Let's talk about the original Schmidt, what is 60 years, more than 60 years old. It's Mr. Ernst Schmidt was an employee with Provosec, and he did the R&D on this original Schmidt and created this instrument. Let's have a look on the work, how it works. You can see here the mass. You can see here the inside. You have a mass, you have the ball. And when we talk about preparation phase, it's loaded. I can show. Then you just, then it's open. I don't do it, but then you press until it is pushing out, because here at the end you have a mechanical system that is, the mass is opening. For the loading phase, is like I said, you do it and then it's pressed. And then the mass will shoot in front and then you get the rebound. When we talk about rebound, the number rebound, we talk about these two instruments. The new version has the value Q. The rebound is fixed in the European norm of EN 12504 minus 2. You can see it. I think everybody got this brochure. It's on page 2 and 3. Yeah? And please, if you have questions later on, here you can see all the time the slide number. Just write down the slide number, your question, and we can follow up later on. And sometimes there's a question from customers because you have a number of 100, like here, but the curve is only up to 55. 55 means it's just a curve for the concrete. And in Japan, you will see a different sticker. So this is the difference. This is just for the mechanical system for the calibration. Usually the anvil has 81. This is 80% of 100%, so that you don't overload the spring and that you don't damage it. Important to see is the formula that you see here. You have a rebound value. It's called R, but usually the formula is quite similar. When we talk about energy following the impact, energy before the impact. We will see with the Silberschmidt, it looks the same. Just here you will see also the velocity. Because on Silberschmidt we use the velocity. When we come to the Silberschmidt, you see already the display. The good thing is in front of here you have the possibility to use the USB stick to connect to the computer. Then you get your reports. With these two, you do the impact, you write. Here you don't write anymore. Especially for reports, it's interesting because you save time. I have to go this side. This is the inside, how it looks like. You can see photo interrupter, what is the difference? A guide rod is all the same. So to get the digital design, you have this photo interrupter, what you will see on the next page. And with this, you can get the Q value. Here is the initial position. Here is again the same system. You have this link that you can get the mass pushed in front. Here you see the photo diode position for the speed on the loading phase, and then you have the impact. It's again pushing in front, and then you have impact velocity, and here you have more or less the formula. Q is 100 times the energy from restored, divide energy from the impact. How did we start this? It's easy to say we have also instruments with for metal. And 40 years ago, we started with the LEAP D design for metal. Metal has a better homogeneity than concrete, so it's easier to test. And with this experience, we created the Silberschmidt. When we come back, here you can see, first it was R, now it is the rebound quotient. This energy and this energy is the same. Here we have another difference because of the velocity. We use the speed to get the result. When we talk about the conversion curves, what are done with BAM. BAM is a big institution, well-known institution in Berlin for Germany, and also a big committee in Germany. They did these tests. Here you can read Digischmidt N with the polynomial regression, and you can see a good correlation because of 0.92. When we come to the Silberschmidt, here you have already 98 because it's easier to handle because of the speed, and you can adjust it. You are not so here on the original Schmidt, you are not so flexible because the mechanical system is fixed. And on the Silberschmidt, you can adjust it, you can create your own curves, like customized curves. So you get the excellent correlation, more or less close to 100. With these informations, BAM and Provsec started to do the test that we get a reference curve, what is more or less fixed as a standard curve on the Silberschmidt, so that you can use it. So at the beginning, when you start with this, is good. It's like with the original Schmidt, you can start with this curve. And then when you have more experience, you can create your own curve, because this is done in Germany and in Switzerland. Maybe in Iran or in, I don't know, in South Africa, the concrete is a bit different, so you can do your own curve, and then you have calibrated the instrument to your concrete. Let's have a short look on the settings. You see the single shot is just if I do one test, then I get all the time saved data. Statistic, I can use the statistics, and then I can key in. Give me a second. The ASTM norms, the media norm for Europe, an average. Like ASTM needs 10 impacts, media needs 9 impacts. Otherwise, you cannot stop and summary. Here on the function, you can see, you can select the function, then you can use the reference norm, what we just saw, or the 10 percentile curve, what is more conservative and is good for fresh concrete. It's not parallel. Sometimes it's confusing because it's spraying up on the top. So when we come, it's more for the fresh concrete. So it's parallel on the bottom, and then when it's getting steeper, the curve, I can go back. So it would, the 10 percentile would go this way. So that's why the 10 percentile curve is good for the fresh concrete. So we have seen the reference curve. The units is just, I have seen here, we talk about Newton per square millimeter. You talk about megapascal, is more or less the same. If I have flat surfaces, I use the cube. I can set it. If I have a round surface like this, I can use the cylinder because the area will be minimized. So the calculation will be done from the software. One is missing. This is for carbonatization. I can say, okay, if I do a lot of tests with carbonatization, I can also key in. It's just a multiplicator. If I know it is 7 megapascal, but the instrument is showing me 10, and then I see, okay, there's carbonatization, I just say, okay, I use this, and 10 times 1 is 10. I just key in 0.7. 10 times 0.7 is 7. So this is my experience. In this way, the instrument is only an assistant. This you can see how a customized curve is done. I have one more. Give me a second. We will see another customized curve, so I skip it. Here you can see this is the report you get on the software, on the PC with the software. You can still, like here you can see there's median, you can still change it. I did some mistake. I keyed in median, but I want to have ASTM, so I just change it. Important to know, on this instrument, if I do a wrong setting, everything what is software related, I can change later on. Everything what is here misread, because here I have to see, do I use the instrument vertical down? Do I use it vertical up or horizontal? If I write a mistake, the mistake is done. Here I can see, okay, I used median, but I want to use ASTM, so I just change it. When we have a look as a summary on those instruments, on the Schmidt family, you will see that with Silberschmidt, you have the highest possibilities. With the original Schmidt, N and NR is the Digge, with paper roll, and the Digge Schmidt is with a user interface. You have some of those options also, but not as many as with Silberschmidt. Here you can see the plunger, what I have mentioned before. Sorry, I didn't bring it with me. It's this size. It's from 5 megapascal up to 30 megapascal, and it's a must to do your own customized curve with the experience on your concrete. Otherwise, you will get different results and you won't be happy. Here you can see one more time what I have said at the beginning. N-type has 2.2 Newton meter. L-type has 0.735 Newton millimeter. So it's the first picture we saw. If you look for a new instrument and you want to see, you want to test fresh concrete, you use one of those, the L hammer and this. If you go higher, you can also use the original Schmidt. And if you do high-rise buildings like in Dubai and somewhere else, you go for the Silberschmidt, because you can do your customized curves and you have higher compression strength. No, you cannot hear. First you wanted to see the anvil for calibration of the Silberschmidt and the original Schmidt. If you do the Silberschmidt, you need this plastic form. If you use the original Schmidt, you take it off and then you just test it. You can see here, you can't read, but here's 81 plus minus 2.